So our first lesson today, we're going to talk about relations and functions, some vocabulary we're going to cover today: domain, range, relation, function, and then for our second lesson, we're going to look at inverse functions. So relation versus functions: a relation is a set of ordered pairs. Your ordered pairs are essentially just input and output values. So there's an example: the ordered pair is 0, 1, the input is 0, the output is 1. The second order pair, 2, 3, input 2, output 3. 4, 5, 2, 6. A function is a special type of relation where every input only has one output. So I always talk about vending machines. If I go to the vending machine and I push the Mountain Dew button, I should only expect to get a Mountain Dew out. If I push the Pepsi button, I expect a Pepsi. If I push a water, I should get a water. Something would be wrong if I pushed the Pepsi button and it gave me a Dr. Pepper. So a function is if you push a button, so you have that input, you expect the same output every single time. You don't expect multiple outputs if you're pushing the same button. So that's what it means to be a function. So when we look at functions, we just check the x values. If you have no x values that repeat, you can't have that problem. So here we have x values of 0, 2, 4, and 6. Those are our inputs. If I'm pushing 4 different buttons, it's okay that I have 4 different outcomes. Also keep in mind that when I was in high school, we had a water machine because we weren't allowed to have pop. We could push all the buttons and still get the same water. So you could have multiple buttons that you press that give you the same outcome, but if I'm pushing the same button, getting different outcomes, that's where your problem is. And then for every set of ordered pairs, you have a domain. Your domain's all of your inputs or your x values, and your range is all of your outputs or your y values. So looking here, sometimes they give you a relation in a table. So this is what a relation will look like in a table. The numbers over here to the left side are your domain or your inputs. And then the y values over on the right side are your values for your range or your outputs. That's the result, what you get when you press that button, or you insert that value. On the next one, sometimes you'll see domain and range problems talking about graphs. So here we have a graph over to the right side. I went ahead and gave you the ordered pairs for those because some of them are decimals, which aren't very nice. And then we're asked to find the domain and find the range. Well, remember, the domain is all of our x values. So if I look at this problem, the x values on my screen are actually in pink. So it's all of the first numbers in your ordered pairs. So the 2, 3, 4, 5, 6. One thing here is we don't list the 6 twice. So we would just say 2, 3, 4, 5, and 6. And you wouldn't even have to put them in. And again, since that 6 on there twice, you do not have to list it twice. And then for my values of my range, your range is all of your y values. On my screen, they're in blue. One thing I will point out, when we write the values for domain and range, we normally write them in numerical order. So we always start with the smallest one first. So 4, then 4.5. Then we have this 5 over here that we're going to list next. 7 and 7.5. So 4, 4.5, 5, 7, and 7.5 are all the values of your range. And then I could ask you, is this a function? So no, it's not a function because we had two buttons that were pressed that were the same. They gave us two different outcomes. So that's pushing that water button and it's giving me a cherry Coke and it's giving me a water. It's not giving me the same output. You can also look at your graph and do what we call the vertical line test. If I can draw a line on a graph and it crosses 2 points, a vertical line that is, and it crosses more than 1 point, it's not a function. So this would not be a function. Let's practice some of it. So here we were given 3 t-charts and we're going to determine whether these relations are functions. So again, when we talk about relations, we only care about the x values repeating. So I'm only looking down this list of numbers to begin with. If nothing repeats, we're good, it's a function. In this case, we have -2 that repeats. If something repeats, you gotta look across and see, did you get the same output both times? No, one time I got a 3, one time I got a 5. Since they're different numbers, this is not a function. There's a question on your next test, but that gives you ordered pairs, and you have to look at them and determine whether it's a function or not. So you're looking just at the x values. So go to this one in the middle, look just at your x values. Do any of those x's repeat? No, they don't repeat. I don't have to worry about anything. It's automatically a function. Only when a number repeats do you have to check that second step. The one on the right, I'm looking, anything repeat? No, it is a function. So sometimes this confuses some students because all of your y values are the same. It's like going to that vending machine that only sells waters. You can push any of the buttons and you're still getting just a water. So don't let the y values confuse you. Focus on the x's first. If nothing repeats, move on. So it doesn't matter that all those y values are the same. If you have a graph, you can use the vertical line test. So if you can draw any vertical line that passes through the graph more than once, it is not a function. So looking here, we have 3 graphs. So looking at these 3 graphs, if I can draw any vertical line, so remember vertical goes up and down. So say I draw this line right here. It's crossing my graph, the original graph, right here and right here. Since it crosses 2 times, it is not a function. And we're not going to worry about domain range. I want you to look at B and C and see if you can make a decision, if this is a function or not. So for letter B, I can draw vertical lines kind of anywhere I want. None of those vertical lines are crossing through my graph more than once. Oops, that one missed, but you get the gist. So this one is a function. So yes, it is a function. None of those vertical lines, I can pick them up and move them anywhere on my graph and not get it to cross more than once. Part C is kind of similar to the book question we had earlier. Is there a spot on this graph where I can draw a vertical line and get it to cross through more than 1 point? It's actually 2. So you could draw this line or this line, and either one of those tell you this is not a function. Because if I draw this line on the left, it crosses through this point and this point, which makes it not a function. If you looked at the one on the right, this point and this point make it not a function. So function notation, we use function notation. It's just an f with an x in parentheses. That's called f of x. It's the same exact thing as y. So sometimes you've seen it on your assignments. Just means f of x. It means it's a function, and the variable is x. So a function is a special type of relation where every input has a unique output. If you take the function, you plug in x, you're going to get y. So x is going to be your input, f of x or y will be our output. So looking at this question here, we're given the function f of x. Remember, f of x is the same thing as y. Don't let that trick you. And I'm asking you to find f of 1, f of 2, and f of negative 3. What this really means is go to this function. So we're going to function f. Function f's right here. And then we're going to plug in 1 anytime we see an x. So we're replacing this with 1 and this with 1. When we plug it in, we're going to put it into parentheses. So f of 1 equals 2 times 1 minus 3. And then we're just going to simplify. 2 times 1 is 2. 2 minus 3 is negative 1. So f of 1 equals negative 1. For the second question, we're going to find f of 2. Going back to that same function, I'm going over here. So f of 2 means go to the function. Anytime you see x, replace it with 2. So 2, then my x, which I'm replacing with 2, minus 3. So 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 is 1. So f of 2 is just 1. See if you can do the last one. So take the function, plug in negative 3 this time. So for f of negative 3, we're going to take the function, we're going to take out the x's, replace it with negative 3's. So 2 times negative 3, minus 3 is negative 6 minus 3, which is negative 9. So f of negative 3 equals negative 9. Questions on these three before we make them a little bit more tricky? All right, on the next page, we are finding f of negative 2 if f of x equals x squared minus 1. So they're giving us a new function, x squared minus 1, and they're asking us to find f of negative 2. So f of negative 2 equals, I'm again just copying down the function, except anytime I see x, I'm putting negative 2 in parentheses. So negative 2 squared minus 1. We're just taking this x out, replacing it with negative 2 in parentheses. The parentheses are really important. So when I go to simplify this, I'm going to take -2 squared. Well, -2 squared means -2 times -2, which is 4, minus 1, which is 3. And this right here is my final answer. So notice we're never doing anything with this first part here. So sometimes I've had students in the past who want to divide by -2 to get f by itself. You don't do that. So that tells us that we took the function, we plugged in -2, and we got 3 for the answer. The one down at the bottom says if f of x equals 1/2 x minus 14, find f of -20. So we're going to the function, we're plugging in -20 anytime we see x. So 1/2 times -20 minus 14. So 1/2 times -20 is -10. -10 minus 14 is -24. So final answer, -24. So took the function, we plugged in -20, the answer we got was -24. All right, so the only really tricky thing they can do with this is if they tell you the output. So sometimes they'll tell you the output instead of the input or the x. So for this one, we're given a function f of x equals 2x minus 3. And then the key thing here, they're asking you to find x. Anytime they tell you the output, they're going to say, hey, find x. That just means I'm telling you the output instead of the input, because x is our input. So here they tell us that f of x equals -5. So I'm going to f of x right here, and I'm going to replace it with -5 because that's what f of x equals. So really we have -5 equals 2x minus 3. Basic algebra 1 problem you need to solve. So add 3 to both sides. That gives you -2 equals 2x. Divide both sides by 2, and you get x equals 1. Yes, -1, thank you. You could double check your answer. If I plug -1 back in for x, I should get an answer of -5. If I would have checked my positive one that I wrote, I would have figured out that, hey, I didn't get -5, so I had something wrong. The one down at the bottom says, given this function f of x equals 0.2x plus 7, find x. That tells me, hey, I'm given the output, f of x equals -5 again. So I'm going to f of x, and I'm putting it there. So -5 equals 0.2x plus 7. Subtract 7 from both sides, so -12 equals 0.2x. Beside it, divide both sides by 0.2. Oops. to get x equals negative 60. So sometimes students get confused with this. We took 12 and we divided it by 0.2 and we ended up with this large number of 60, well, negative 60. But so really you're taking negative 12 and you're breaking it up into 0.2, so you're breaking it up into small pieces. So you're going to have a lot of it. So see if you can do the last two problems on the next slide. So f of x equals 6x plus 14. And then you have one problem where they give you the input, one problem where they give you the output. So one of them you're finding the output, one of them you're finding the input. So for the first one, they ask you to find f of 3. They're telling you go to the function and input 3. So going to the function, inputting 3, that gives me f of 3 equals 6 times 3 plus 14. Well, 6 times 3 is 18. 18 plus 14 is 32. So f of 3 equals 32 is my answer. The next one's the tricky one. They're telling you to find x. That's your key that they're telling you the output, and you're asked to find the input. So f of x equals 7. So 7 equals 6x plus 14. Subtract 14 from both sides. So negative 7 equals 6x. Beside it, divide it. X equals negative 7/6. And as always, I would just suggest you leave that as an improper fraction. You could, again, plug it back in to make sure it gave you an answer of 7. Questions or concerns? All right, on the next page, you have some problems to work on. Let me know if you get stuck, need help,